Okay, good morning, dear students. This is the 15th part determinant, 15th part, 14 parts we successfully completed. In that one, exercise 4.5, 11 problem is solved. Now we are going to find the 12, 13, 14. These are important problems, essay type questions. And the 17, 18 are objective type. Okay, na? Yeah, observe. 12th one. 12th one is capital A is 3, 7, 2, 5. One matrix is given 2 by 2 matrix. Capital B. B is also a given matrix 6, 8, 7, 9. And we have to prove that AB whole inverse is equal to B inverse A inverse. This theorem is there with the proof also, but it is not needed in our syllabus. Not needed. For knowledge purpose, how can we prove AB whole inverse is equal to B inverse A inverse? But in our syllabus, by taking one example also I solved in the previous videos. Here also this exercise problem is also important. Now we are going to prove that one. We are verifying that property AB whole inverse is equal to B inverse into A inverse. Okay, we come to the problem. We are given AB, then that A 3 into 5 minus 2 into 7. That is 15 minus 14 is equal to 1. Yeah. Similarly, it is that B, determinant of B is equal to 6 into 9 is 54 minus 7 into 8 is 56. That is minus 2. Okay, now? So, 1 is determinant of A, B is for B determinant is minus 2. Adjoint A. Adjoint A means A, B, C, D. A, B in the first diagonal, it will become as a interchange B, D, A. And here B, C is there. It is minus B, minus C. Okay, na? You see there. Already I told you, if A is equal to, it is A, B, C, D. Then adjoint A is nothing but it is D and it is minus B, minus C and it is A. In the first diagonal, the elements are interchanged. In the second diagonal, it will be minus, negative of those elements. So it is okay. Similarly for B also, adjoint of B is equal to that 9 minus 8 minus 7, 6 will come. Now, A inverse. A inverse is equal to 1 by delta A into adjoint A. A formula is there. 1 by delta A is 1 by 1. Determinant is there. Adjoint A error. So we get the same. Okay, now here it is A inverse. Again same B inverse is 1 by delta B into adjoint B. 1 by delta B means 1 by minus 2. Minus 2 is there, delta B. Adjoint B is already is there. It is put as it is. I am not sending minus 1 by 2 inside. If you send it, okay. But as it is, you simply leave it out. A inverse is this one, B inverse is this one. Only. Now, consider B inverse into A inverse. B inverse is 1 by minus 2 as it is. That is minus 1 by 2 I wrote. And same elements. A inverse is also is there. 5 minus 7 minus 2, 3. Now, minus 1 by 2 is as it is. That is a multiple of a constant. Now, these are the multiplication of two matrices. 9 5 is 45. It is minus 8 into minus 2 plus 16. 9 into minus 7 minus 63. It is minus 8 into 3 is minus 24. Similarly, minus 7 into 5 minus 35. 6 into minus 2 minus 12. It is minus 7 into minus 7 is 49 plus the 49. 6 3 is 18. Then addition, the sum is 45, 16 is 61, it is minus 87, it is minus 47, it is plus 67. Minus 1 by 2 as it is, I put as it is, I didn't multiply the elements by this constant. As it is, I simply keep it out. Say this is 1. What is the equation 1? We solved B inverse, A inverse. As this one, say it is equation 1, okay. Now again, we consider A into B. AB is there. We find the AB product A into B. It is also 8, 6, 18, 3, 6, 18, 7, 7, 49. It is also 24, 63, 2, 6, 12, 35. It is 16 plus 45. We get 67 something and something. 87, 47, 61. This is AB product of AB. Now, for this matrix, AB is again a matrix some x. What is the data of x? What is the determinant of this matrix for this one? 67 into 61 minus 87 into 47. We get 4087 minus 4089. We get minus 2 is the determinant of the product of A and B. Okay, now adjoint of AB. Say this formula AB. We interchange the elements in the first diagonal and negative of the diagonal of second, negative of the elements of the second diagonal. Okay. Now we find AB whole inverse. AB, let it be x. X inverse means 1 by det x into adjoint x. 1 by det x means this one is already minus 2 is there, and adjoint of AB is already is there as substitute. Here, say it is this AB whole inverse, let it be equation 2. Here, B inverse into A inverse is this one. From 1 and 2, you observe meaning. From 1 and 2, both are same. Same 61, 87, minus 47, 67. Okay, now in the outside the multiple is constant is 1 by minus 2, 1 by minus 2. So we may conclude that from 1 and 2, from 1 and 2, AB whole inverse is equal to B inverse into A inverse. That is we prove. Okay, now like that you have to prove. Yeah. Yeah. 13th problem. 13th problem is a dated problem. Wrote it. It is also dated. We are given a matrix, matrix A, and we show that A square minus 5A plus 7I is equal to 0. In the textbook, we are given only here 1 is given. It is 3, 1, minus 1, 2 is there. Okay, na? You correct it. Okay, na? Then only we can prove this one. A square minus 5A plus 7I is equal to 0, and hence we have to find. We have to find A inverse. First we find, we show this one. Observe me. We are given the matrix capital A is equal to 3, 1, minus 1, 2. Here minus 1 is there in the textbook, 1 is given. But it is wrong, it is correction is there, 3, 1, minus 1, 2. Then what is A square? A square means A into A. A into A means 3, 3 is 9, it is minus 1. 3, 1 is 3, plus 1 into 2, plus 2. It is minus 3, minus 2. Minus 1 plus 4, 2 into 2, 4. So we get 8, 5, minus 5, 3. That is the matrix A square. Now we consider, that is A square minus 5A plus 7A. A square is already is there, 85 minus 5, 3. 5 into A, 5 is given, 3, 1, minus 1, 2, A, plus 7 into I means identity matrix are unit matrix, 7 into 1, 0, 0, 1. Now, you observe me, this is 5 into 3, 15, 5, minus 5, 5 to 10, 7, 0, 0, 7. Now, 8 minus 15 plus 7. Be careful. 8 minus 15 plus 7. It is minus 5 minus 5 plus 0. It is minus 5 minus minus plus 5 and plus 0. And here is 3 minus 10 plus 7. This is 0, 8 minus 15 minus 7 plus 7, 0, 5, 5, 0, minus 5 plus 5, 0, 3 minus 10 minus 7 plus 7 is again 0. So at last we get a null matrix or a zero matrix. Its notation is 0. That is here it is 0 matrix, not constant 0. It is the notation 0 matrix. Yeah, we proved. Now we are going to, by using this a square minus 5a plus 7i, through that one I am finding the A inverse. Be careful. A inverse we know it by finding that A and adjoint A. A inverse is equal to 1 by that A into adjoint A. We get the same. That one answer. But here the concept is, what is the concept of asking this question in the exercise means, we already proved this, we shown this a square minus 5 plus 7i is equal to 0. By using that proof, that expression, we have to get A inverse. That is the concept header. So already we have a square minus 5a plus 7i is equal to 0 na. A square minus 5a is equal to minus 7i na. A square, we are multiplying on both sides with A inverse. Be careful. We are multiplying with A inverse. A inverse of LHS, A inverse of RHS. Okay na? A inverse into minus 7i. It is very simple. Okay na? It is minus 7 is a constant. A inverse into I here. And here it is A inverse into A square. A inverse into one more, one A is there and again A is there. A inverse into A is I. I into A, I. A. Here minus 5, A inverse into I is written. It is minus 7, A inverse into I is simply A only. If we multiply A with any matrix, we get that matrix only. I into A inverse is A inverse. Okay now? Here A inverse into A inverse, the definition of inverse is I only. I into A we get. I into A is again A. Here A only. Be careful. Here we get A only. 5i. It is a minus A, 7A inverse. So A inverse, we are asked to find A inverse. A inverse is equal to minus 7 goes this side. Minus 7. Instead of minus I, interchange 5i minus A. Not A minus 5a. 5i minus A. So 1 by 7 into 5i minus A. What is 5 into I? 1 0 0 1. What is A? 3 1 minus 1 2. This is 5 into 1 5 minus 3, that is 2. And it is 5 into 0 0 minus 1 minus 1. 5 into 0 0 minus 1 minus plus 1. Yeah. 5 into 1 1 5 minus 2, that is 3. So at last we get this one. This is not given. You stop here on. So this is the A inverse. It is given in the answer. 1 by 7. It is 1 by 7. It is 2 minus 1, 1, 3. That is the A inverse. If you find directly, we get the same thing. But you do like this one. After showing this one, this expression is 0. Then by using that expression, you find the A inverse. Okay now? Right. Okay now. 15th problem. It is also important one. We are given a 3 by 3 matrix. And in this question also, the mistake is there. Be careful. We have to prove that A cube minus 6A square plus 5A minus plus 11I is given, but it is minus 3I. Then only we can get 0. Some correction is there. You see there. I will solve this one. Already I solved on the board. Why? Because in the previously I am solving the problem on the board. Why? Because while teaching, explaining and writing and all calculations, it will take so much of time. That is why I solved on the board. Now I can explain. Okay now? You observe it. A correction is there, minus 3i. And find A inverse. That A inverse I am giving work to you, homework, you find. I can prove this one. We are given A. A is 1, 1, 1, 1, 2, 3, 2, 1, 3. A square. A square means A again A. Multiplication. 1 into 1, 1, 1 into 1, 1, plus 1 into 2, 2. Similarly, 1 into 1, 1, 1 into 2, 1 into 1, 1. Again 1 into 1, 1 into 3, 1 into 3. That is again 1 into 1, 2 into this 2. See, 1 into 1, 2 into 1, 3 into 2, 6. Again 1 into 1, 2 into 2, 3 into 1. You observe my fingers. That is this one. Again 1 into 1, 2 into 3, 3 into 3. This one. Again 1 into 1, 2 into 1, 1 into 1, 3 into 2. This one. Again 2 into 1, 2 into 1 into 2, 3 into 1. This one. Again 2 into 1, 1 into 3, 3 into 3. This one. Okay, now we know how to multiply the matrix, two matrices. This will give, it is 4, 4, 7, it is 8, 8, this is 9, this is 8, and it is 16. It is 9, 7, and it is 14. Now, A cube. How can you find A cube? A cube means A square into A is there. A square already is there, A square into A. Similar way, 4 into 1, 4 into 1, 7 into 2, 14. Like that we have to multiply. 4 into 1, 4 into 2, 7 into 1. That one. Again 4 into 1, 4 into 3, 7 into 3, 21. This one. Again 1 into 9 into 1, 9. 8 into 1, 8. 16 into 2, 32. 9, 1, 8, 2, 16. 16, 1 is 16. You observe my hand and fingers. 9 into 1, 9. Plus 8 into 3, 24. 16 into 3, 48. Again 9 into 1, 9. 7 into 1, 7. 14 into 2, 20. 14 into, 9 into 1, 9. 7 into 1, 7. 14 into 2, 28. Yeah, okay. Again, this row and this column. 9, 1, 14. 7, 2 is 14. 14, 1 is 14. 9, 1 is 9. 7, 3 is 21. 14, 3 is 42. Its answer is 22, 19. That is 23 plus 4, 37. 17. This one is 49. And 32 plus 9 is 41. This is, observe me, 48, 24 is 72 plus 9, 81. Yeah. This is 13 plus 28. Observe me. This is 9, 16. 16 plus 28 is 44. It is 14, 14, 28 plus 9 is 37. Yes, it is correct. So we calculated A square and A cube. It is arithmetic pure. Nothing is there. It is very simple. Knowledge is nothing is there. Intelligence is not there. Only arithmetic. Okay, now be careful. We find A square and A cube. Now we substitute those values in that expression in order to get 0. So A cube was 6A square plus 5A minus 3I. Okay, now a correction is there. You try to correct it. A cube is written, 6 into A square is written, that A square, 5 into A, the same matrix given, and minus 3 into I. Minus 3I directly, I wrote minus 3 into I is 1, 0, 0, 0, 1, 0, 0, 0, 1. I multiplied to put it here. You see, it is minus. Now this is 22 minus 6 into 4, 24, plus 5 into 1, 5, minus 3. Okay, na? Here you see it. 22 minus 24 is minus 2 plus 5. 3 minus 3 is 0. Here also 19. This is somewhat difficult. 19 minus 24 and 5 plus 5, that is 0. It is 0. Okay, it is also 0. 19 plus 4 is 24 minus 24 is 0. Like this, you slowly try to find out. Everywhere we get a 0, 0, 0. Okay, na? So it is a 0 matrix, a null matrix. Okay, na? Like this we have to solve. It is important problem, but arithmetic is plus minus very difficult, very confusion. Be careful. Like these problems are asked in the exams. Be careful. And A inverse, you know it, that A you find for this problem by using that concept not possible. The previous problem we solved, but this problem is not possible. You simply leave it out. You directly find that A. You find this one. That A you find under the adjoint A. Okay, na? A inverse. What is A inverse? A inverse is 1 by that A into adjoint A. Through that one you can find the A inverse. Okay, na? Like this you solve. Okay? Yeah.